So let's imagine a parallel plate capacitor problem. So we have two circular plates, and these circular plates, let's say, have a diameter (25 centimeters). And let's say the separation between the two metal plates is going to be 0.875 centimeters. Okay, so first thing I'm going to ask for is, what is the capacitance of that system? Okay, well, you know that the capacitance is going to be epsilon naught A over D. So this would be epsilon naught pi r squared over D. All right, so that means we could then write that the capacitance is epsilon naught 8.85 times 10 to the minus 12 farads per meter times pi times 0.125 meters squared. Remember, it's half diameter, divided by 8.75 times 10 to the minus 4 meters. So the capacitance comes out to be 4.96 times 10 to the minus 10 farads. Or in other words, that would be 496 picofarads. Okay. Or you could write it as, if you wanted to, you could write that as 0.496 nanofarads. But for whatever reason, nanofarads are rarely utilized. All right, so we got our parallel plate capacitor that we just calculated. Okay, two metal plates. I gave you the area and the separation, and we calculated that the capacitance was 496 picofarads. Now, if I were to connect that to a battery, 9 volts, what's going to happen? Well, we're going to end up with positive charge on the top, negative charge on the bottom. Okay, and so what I want to know is how much charge was transferred and how many electrons. Okay, so we know that capacitance is defined to be Q over V, so Q is going to be C times V. So in this case, that's going to be 496 times 10 to the minus 12 farads, okay, times 9 volts, and that's going to come up to be 4.46 times 10 to the minus 9 coulombs. So that's how much charge was transferred. Well, we can take that 4.46 times 10 to the minus 9 coulombs, divide by the fundamental charge, 1.602 times 10 to the minus 19 coulombs per electron. And that's going to tell me I've got 2.79 times 10 to the 10 electrons. So 27.9 billion electrons were removed from the top plate, and 27.9 billion electrons were added to the bottom plate. And so this is how many electrons. So those were removed from the top, and that many were added to the bottom. Okay, because we have positive charge on the top, negative charge on the bottom. And so where did these electrons come from? Well, they ultimately came from the battery and went into the battery. So that's what your power supply is doing. It's shoving electrons around or pulling electrons off.